Hello students, welcome to my channel. And in the previous videos actually I explained the examples and properties related to exercise 2.1, and I also solved all the questions of exercise 2.1. So today we will learn about sets related to exercise 2.2, and I hope all of you understood whatever I explained in the previous video. If there is any issue, please inbox me, so I will try to explain again. So let us start from the page number 44, 2.4 sets. Now sets means actually it's a collection. First of all, you must know about the collection of anything, collection of students, collection of any data, a collection or a group. So suppose class 9 students, the collection of 9 students, there are 40 students suppose in class 9, so that 40 students will be called collection, or it is a group. A collection or a group is called a set if we are certain about that which elements belong and which elements do not belong to that group. In other words, element belonging to the set should be well defined. So main important part is that well defined. Whatever collection we will do, that must be well defined. So suppose the collection of the students who scored 60% above, suppose in advanced maths, suppose we have to collect the data of students, those who scored 60% marks or above. That means 60 to 100%. 60 to 100%. So if there are students, suppose 5 students are there, suppose 2 students are there may not be any students, then we will put 0. How many students scored 60% and above in class 9 of such and such a school? So suppose there are no students who scored 60% and above, then we will put 0. If there are 5 students, that means there is a collection. There is a meaningful collection. Either 5 students, 2 students, or no students. So this is well defined. It is called well defined. But if we write students who are good in mathematics, good in maths, or poor in maths, or who are talented, so this type of, these are called adjective, as you know, these are called adjectives. Quality can be measured, but there is no fixed measurement. So for me, good students, maybe 50 to 60% students, 50 to 60% scores in mathematics. For some other teachers, good means 60 to 80%. For some teachers, 80 to 90% those students scored marks in mathematics, they may be good. So there is no fixed definition. So good, bad, talented, not talented, so that cannot be measured. That cannot be measured by any number. So this is called not well defined. I hope you understand. Not well defined. Not well defined. Now suppose this room, now it is night, the light of this room is better or good or not good. So good, not good, better, these are adjectives. So whenever we use adjectives only without any measurement, that is not called well defined. So there must be a particular definition that from which we can understand the measurement. Measurement must be there. So only good, bad. So suppose today is the collection of bad weather during the month of June. Sorry, this is month of May. So collection of bad weather during the month of May till today. So for you, bad weather means maybe for you rainy, when there is raining, that may be for you bad weather. But for me, for any other person, if there is very hot days, those days may be bad weather. So that there is no fixed definition. So this type of adjectives whenever we use, so it is not called well defined. So and suppose students who scored 30% in class 9. So there may be some numbers. There will be some numbers. If there is nobody scored 30%, so there will be 0. 0 or any number will be there. If I say there are good people or noble people or gentlemen, collection of gentlemen in your area, collection of good people in your area. So how can you measure? You cannot go for the measurement. You will not have any measurement. If the person is looking good, may be gentle, may not be gentle. The person is looking good, behavior is good, but inside you don't know actually he is good or not. Or even he is good, how much good, how much bad, how much gentle, that cannot be measured. That is why this type of words whenever you will get in sets, they are not well defined. So what is the conclusion? In other words, elements belonging to the set. Set means collection, any collection of data. The set should be well defined. So please remember the word well defined. Any set. A is equal to A, E, I, O, U. This is a set. This is a set in which 1, 2, 3, 4, 5 elements are there. They are called, each one is called elements. Element. Each one is called element. And whatever elements are there, if there may not be any elements, maybe there are 100 elements, 1000 elements. So this type of figure is called set. The name of set is set A. So generally when we denote a set, we use capital letter of alphabet. We use the capital letter of alphabet. So again, let me show you n. N means we know natural number. So we can write 1, 2, 3 like this. This is a set of natural number. This is a set. What is the name of the set? Set is n. What are the elements? 1, 2, 3, 4, 5 till infinity. We don't know the ending. This is also well defined because there are some elements. Measurement is there. So this is called set n. Set n. So that is why I have showed you, I have already told you that capital letters will be used for set, for name of set. So set, I hope you understand, any collection which are well defined. Now generally here there is one example is given. S, A, B, C, D, E. The name of the set is S. Elements are A, B, C, D, E. Or if anybody asks how many elements are there in set S, 1, 2, 3, 4, 5. There are 5 elements in set S. So this type of braces, this is called braces or second bracket. We can say second bracket also. We can say anything, but you can have to remember the sign, because what this bracket is called, you will not come in exam. So we don't need what is the name. Name does no name has no importance, but you must know what type of symbol will be used for set. Again, set A. -3, -2, -1, 0, 1, 2, 3. So this is a set in which 1, 2, 3, 4, 5, 6, 7. 7 elements are there. They are called, each one is called element or member. We will use the word element. These are all the members of this set A. So here it is written, are also called members of set S. Now, which member is present in which set, that how can you express, how can you represent? Suppose the letter B is present in set S. Letter B, small letter of B is present in set S. So this is the symbol. This is epsilon. The name of this symbol is epsilon. This name of this sign will not come in exam, but you have to learn how to write the, how to express, how to write the symbol this way and this way, like E, no, like capital letter of E. So this B, which is called belongs to, how do we read? B belongs to S, or little ahead, B belongs to set S. 0 belongs to set A. 0 is present in set A. So 0 belongs to set A. 0 does not belongs to set S. Belongs to, does not belong to. So this is the symbol you have to use for belong and does not belong. Belongs to or does not belong to. So I hope you understand. If it is not, so you will cut it. Now, so there are so many sets you will get in your life. In class 9, in class 10, like that, you will go on getting so many sets. Now set which is blank. There is a set B. The set, this is a set, but there is no element. No elements are there. Empty set. That means no elements are there. So which we say, which we express by this letter. This is Greek letter phi. We say it is phi. Whenever there is empty set, no elements are there in the set, that set is called null set. Null set, which expressed by the symbol phi. That means phi is called null set. When do we get null set? For example, A is a set. Suppose A is a set of natural number less than 0. Natural number starts from 1. That we know already, isn't it? Natural number starts from 1. So there is no element, there is no number less than, there is no natural number less than 0. Less than 0 means there will be negative number. Negative numbers are not natural number. So A is a set in which we will not write any elements, because less than 0 there is no natural number, or shortly we can write phi. A is equal to phi. It will be understood by us that A is a set in which there is not a single element. No elements are there. I hope you understand what is phi, what is null set. For the name, it is called null set. For the symbol, it is phi. I hope you understand. So, suppose in your place, somebody told you to collect the tigers available in your locality, tigers or lions, and you know that there is not a single tiger or lion in your locality, because tigers and lions, they live in zoo. So that in that case, the set of name of the set is A, suppose, so that will be 5. So this way, if you don't get any elements, then that will be called null set and denoted by this symbol. The name of this symbol is phi, and phi is a Greek letter. Phi is a Greek letter. So I hope you have understood what is set. Set is well-defined collection of well-defined objects. Set is, shortly, set is a collection of well-defined objects. So if it comes in exam to write the definition of set, very simple. Set is the collection of well-defined objects. You have to use that well-defined word. Secondly, what is called null set? The set in which there will be no elements. Not a single element will be there. That set is called null set. Finite set, infinite set, that you know, I think, I hope. Suppose this is a set. Here I have written 1, 2, 3, 4, 5. This is finite set because there is ending. If I write 1, 2, 3, 4, 5, no ending. So infinite set. Now that is very simple. That is common sense. Infinite set, very simple. That you don't have to learn so much about that. There is ending, finite set. If it is in no ending, is going on a ring, so that is infinite set. Infinite or infinite set, no problem. Okay. Now, let me explain something about the method of expressing a set. There are two methods to express a set. This one I have wrapped, I have erased it, so you can pause the video, you can note it down, or you can check it again and again, no problem, because it's a video. So now we will go to learn about the expression of how to express a set, and there are two methods. One is roster or tabular. Other one is rule or set builder. Two methods are there. So roster or tabular means we will write the elements directly. We will write the elements directly, but here we will not write the elements. We will not write the elements. We will not write the elements, but we will show the elements without writing the elements. We will make people to understand what are the elements. If I say A, for example, A, E, I, O, U. If I say vowels of English alphabet. So I have written two types. I have written directly the vowels, but here I have written about the vowels in sentence. So this is called roster method and this is called rule method. This is called tabular form. This is called set builder form. So here we have the meaning of both this part and this part, both are same. But here directly elements are written, but here about the elements it is mentioned. Again, 1, 2, 3, 4, 5. and again this is number 1, this is number 2. The first 5 natural numbers, same meaning. So this is what, this is called roster method, this is called rule method. So now we will have to use in the both cases braces, second bracket or braces, whatever you say, that must be used, because in a set this must be there. This sign, this braces or second bracket must be there, otherwise it will not be called a set. Set must have the braces starting and ending. So for example, now we will write properly. Now. Suppose -2, -1, 0, 1, 2. These are the elements. Let us write the set A in which in roster method -1, 0, 1, 2. The same set we will write now in rule method. How do we write? There are so many processes. We can write X such that X belongs to Z, comma X is greater than what and X is smaller than what. That is what we have to here. We have to write that. That already I explained in previous videos how to write. What is X? What X mean? X means this. These elements means X. So -2 and 2, starting from -2 and ending at 2. So X is greater than -2 and X is less than equal to 2. X is greater than equal to -2 and X is smaller than equal to 2, or X is greater than -3, X is smaller than 3. I hope you understand this, the meaning of this and this. Here starting from -2 ending at 2. Here not starting from -3, because X is greater than -3 will be -2, -1. -2 is greater than -3, as you know that. Negative number. X is smaller than 3, that means till 2. Till 2 we will write. So meaning is same. Elements will be same. Only way of expression is different. Either this way or this way. Both will be correct. If you know the meaning of this symbol, then you can understand. If in class 9 now you are, so you must understand what is the meaning of these symbols. This is X is greater than equal to -2, X is smaller than equal to 2. That is how to read it. This one, X is greater than -3 and less than 3. So meaning is same, elements are same. So this is called rule method or set builder method. So both the way we have to learn. Sometimes what happens, so many elements are there, so we cannot write all the elements together. Suppose there is then the set of natural numbers less than 100. Set of natural numbers less than 100. That means 1 to 99 we cannot write. It will take so much space and it will take so much time also. In that case, suppose now the set is A, then we will write X such that X belong to natural number, X is less than 100. That means till 99. What is X? X is natural number from 1 to 99. So we will write X is less than 100. X belongs to, first you have to write, then by putting comma we will write about X. So in that case we need this rule method. Otherwise we cannot write it. You can write, but it will take time. 1 to 99 it will take so much time. So in that case, we will avoid writing the elements directly. We use rule method. I hope you understand. Here some examples are there. 1, 2, 3, 4, 5. So n, these are, you can write x or n, no problem. N oblique n or n such that n belongs to natural number. N is smaller than 6. Smaller than 6 till 5. 1 to 5, they are natural numbers. So n belongs to n or x belongs to n, no problem. Capital N you have to use for natural number. So till 5 it is, that means n is less than 6. That is what you have to write for rule method. Now we will learn about subset, which is very, very important for you. Subset. The meaning of subset. This is very, very important for you. A set A is a subset of set B if and only if every element of A is in B. There are two sets, A and B. All the whatever elements, maybe 100 elements, 1000 elements, if all the elements of this set are present in set B, then we say A is subset of B. This is the symbol of subset. All the elements of A are in B. Suppose A has got 100 elements, 1 to 100. B has got 1 to 200. A is a set in which elements are written from natural numbers 1 to 100. B is also a set in which element starts from 1 and ending at 200. So all the elements of A are present in B. So A is called subset of B. It is very simple. Very simple. Suppose X is an element present in A or X is in A. So how do we write? X belongs to A. X may be 1000 elements, X may be 1 element, but X belongs to A. So X must belong to B also. Then only we can say A is subset of B. Set, subset. And oppositely, B is called superset. Superset of A. Oppositely, A is subset of B, B is superset of A. Meaning is same. Meaning is same. Now we will learn about, I hope you understand, I will show you an example. A, B, C, D, E. Now set B. A, B, C, D, E, F, G, H. So all the elements of A are present in B. So A is subset of B. I hope you understand properly. There is nothing else. Subset A is subset of B means all the elements of A must be present in set B. Secondly, very importantly, more important than subset, that is proper subset. Proper subset. So this always gets confusion among the students about subset and proper subset. Subset and proper subset same, but there is one special term for proper subset. For example, I will show you example first. A 1, 2, 3. B 1, 2, 3, 4. C 1, 2, 3, 4, 5, 6, 7. Now A is subset of B because all the elements of A present in B. A is also subset of C. Okay, let us write. A is subset of B. A is also subset of C. And B is also subset of C with all the elements of B also present in C. 1, 2, 3, 4. 1, 2, 3, 4. They are also. So this can be written. Now forget about this now. Now A is called proper subset of B. Why it is called proper subset? Also because all the elements of A are present in B and B has got at least one extra element. At least one extra element. Then we can say A is proper subset of B. We also can say B is proper subset of C because all the elements of B are present in C and at least one extra element there is in C. So whenever there is extra element, then we can say A is proper subset. We can use the word proper subset. What? Let me repeat. A has got elements 1, 2, 3. B also has got same 1, 2, 3. But B has got one extra element. At least one extra element if there is, then A is called proper subset of B. Look here again. One more example. P. A, B, C. Q is a set. This one A, B, C. Here also A, B, C. So in that case, we can write only P is subset of Q, but we cannot write P is proper subset of Q. All the elements of P are present in Q, but it has no extra element. So in that case, we cannot use P is proper subset of Q. Subset and proper subset, I hope you can understand properly. You have understood properly. Here, for example, given A, B, C, D is proper subset of A, B, C, D, X. All A, B, C, D. Here also A, B, C, D. It has got one extra element. So this set is proper subset of this. If A is proper subset of B, then there is no element in A which is not in B. By this argument, phi is a subset of every set A. So this is very, very important for you. Phi is subset of every set, whatever set. Phi is always subset of every set because there is no element in A which is not in B. By this argument, phi is a subset of every set A because there is no element in phi which is not in A. A is and B. A, B, C. So A is subset of B. No element. Sorry, subset of B. So phi is subset of every set, any set. Phi is this one. Please remember this one. Please have a note of this. Phi is subset of every set. Now power set. So what we have learned till now, set is a collection of well-defined objects. Next we have learned roster and rule method. In roster method, we write the elements directly, and in rule method, we write the elements indirectly. Next we have learned subset and proper subset. Now we are going to learn power set. The family of all subsets of any set is called power set. Power set of that particular set. All the subset of any set. So I will show you. So let me write some sets without putting and without writing any alphabet, without writing any name. One. This is a set. This braces is there means set. 2, A, B, Q, R, S. So this way I have written 4 sets. Okay, this one 2, 3. Wait. This one, let me write 2, 3. Okay. So 1, 2, 3, 4 sets I have written. I have not put any alphabet for the name of the set. Just directly written 4 sets. In the first set there is 1 element. In the second set there are 2 elements. In the third set also there are 2 elements. In the fourth set there are 3 elements. I hope you understand this one. Now I am going to write a set in which, let me write some. Okay. So now can we say okay, this is a set. One is there, so subset of A. 2, 3, subset of A. They are present in A. They are present in A, and phi is always subset of any set. Phi is subset of any set. A, B, C, any set. So I hope this one you understand. So in this case, what happened? So 1, 2, 3, 4, 5. 5 subsets I have written for set A. I have written 5 subsets. There are many more for this set A. We can write this way also. QR subset of A, because QR is present. So we can write many more. But I have written here 1, 2, 3, 4, 5, 6 subsets for set A. So whatever we write, they must be present in set A. So like this, how many subsets we will get? That's a question now. That is a question now. How many times we will write the subsets? For this set, how many subsets we will get? Let me write one more. 3A. This is also subset of A. 3A. 3A. Subset of A. Because these elements are present in set A. So, subset. They are present means subset. But S, T, not subset of A, because T is not present. So this way, how many subsets we can write? That is a question, and that is called power set. Power set, the family of all the subsets of a set is called the power set of A. It is denoted by the symbol PA, or 2 to the power A. PA means power set of A, or 2 to the power A. So 2 to the power A I will explain you, but power set of A we can write PA. Now here one example is given. I will show you one example separately. A, B, C. This is a set in which 3 elements are there. So how many subsets we will get? Let us write subsets of A. Power set of A we can say shortly. This is the starting braces, and we will end at. Now inside we will write A, B, C. This is a set which is in which element A is there, which is present in set A. So subset. So I think you understand. Subset of A. Subset of A, because this is present. Now A, B, AC, BC. Possible ways we have to apply here. First single, then double, possible. A, B, AC, then BC, no more. After that, 3. First 1, then 2, then thrice. So 3 elements. Then 5. Phi is always subset of any set. This is the starting braces. This is the ending second bracket. So inside this bracket, how many subsets are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 subsets we have got. We have got 8 subsets. So if there are Y, A, B, C, D, E, F, G, H, I, J, K, L, M, like this elements are there. Suppose 15 elements are there. Then it will be so big. It will be so big. 1, 2, first single elements, double elements, triple elements, 4 times, 5 times, so many elements we have to write, so many subsets we have to write, so many subsets we have to use. So how many subsets we will get? We will apply this formula, 2 to the power. Here how many elements are there? 3. How many elements are there? 3. So 2 to the power 3 is a formula. So 2 to the power 3 is 8. That means we will get 8 subsets. This is a formula. This is what written here. 2 to the power a or 2 to the power n. We can say 2 to the power n also, 2 to the power a, whatever it is. But here number of elements. Suppose a is equal to 1, 2, 3, 4, 5. So how many subsets we will get? It will be so big numbers. If we go on writing, it will take time. It will take so much space also. So anyway, how many subsets we will get? We will use 2 to the power 1, 2, 3, 4, 5. So 5 elements are there. That is 2 to the power 4 is 16, 16 to the 32. So 32 subsets. We will get 32 subsets. So this is called power set. This is power set. How many subsets? Subsets are writing for any set is called power set. All possible subsets. Possible. We cannot use any more for ABC. We have double used, single used, triple used. After that, no more. 5 will be always there. I hope you understand about power set. Universal set. Universal set, in the context of discussion of different sets, very often we consider all these sets as subsets of a particular set. Such a set is called a universal set of all these sets. A universal set is usually denoted by capital letter of U. Capital letter of U. Okay. Now, A is a set 1, 2, 3. B is a set 2, 3, 4, 5, 6. C is a set 2, 7, 8, 9, 10. So we have got 3 sets. If all the elements in one set, if we write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These elements all are present in this set, which is called universal set. Universal set. What does it mean? A is subset of U, B is subset of U, C is also subset of this. So this is called, that is why, universal set. All the elements of A, they are present in set U. B, elements of B also present in U. All the elements of C also present in U. So that is why U is called universal set. In the discussion difference, very often we consider all these sets as subsets of a particular set. All these sets are subsets of a particular set. These are all subsets of this particular set, which is called universal set. So that means, suppose A is subset of P, B is subset of P, C is also subset of P, then P will be called a universal set. I hope you understand. All the elements of A, B and C, they are present in one set, that is P. So P will be called universal. But generally we use capital letter of U for universal set. We use the letter capital letter of U for universal set. Now equal sets. Equal sets already I explained actually. Two sets A and B are called equal if and only if A is subset of B and B is subset of A. Why? A 1, 2, 3. B also 1, 2, 3. A is subset of B because all the elements of A are present in B. B is also subset of A because all the elements of B are present in A. Therefore, A is equal to B. Shortly, in rule method, X belongs to A, X belongs to B. Whatever elements are there, that is called X belongs to A. Whatever elements are there, that is called X belongs to B. So A is equal to B. Oh, you can understand. Now some intervals are there. How to use intervals. Number 1, open interval. Open interval means, so let me write open interval A comma B. Both side bracket. Both side small bracket. You can say small bracket, no problem. Which in rule method we will write, this is rule method, x belongs to real numbers. Real numbers, you know real numbers. I am not going to explain again real numbers. If you don't remember about real number, please go through your books. You will understand real number, natural number, integers. So those you can understand by yourself. Anyway, so x is greater than a and x is greater than, sorry, smaller than b. Let me write one number. X is greater than 2 and x is smaller than 5. So that means greater than 2. So 3, 4, 5. 5 we will not write because x is less than 5. So in that case, this is called open interval. This is called open interval and that is denoted by this symbol A, B. A, B. Till A, it doesn't reach. Till B, it doesn't reach. This is X. X is greater than A and less than B. So this is the symbol for open interval. I hope you understand this meaning of this, at least you understand. Number 2, closed interval. Closed interval is A comma B. So same thing we will write now. X belongs to real number such that X how do we read this one? This one we will read X is greater than A and less than B. This one we will read X is greater than equal to A, less than equal to B. It means suppose 3, 7. X is greater than equal to 3 and less than equal to 7. So we will write 3 here. 4, 5, 6, 7. Here x is greater than a. We will not write a. But here x is greater than equal to a. Equal is there. That means we have to use 3. We have to use 7. Equal sign is there. X is equal to 7. And the rest x is smaller than 7. So 7, 6, 5 like that. I hope you understand. This one symbol is like this. A, B. That means A is included. Here A is not included. B is not included. Here A is included. This is A. That means 3. 3, 4, 5, 6, 7. This is 7. This B is 7. I hope you understand. This is the way of expressing in number line. You know number line? So this is what you have to express in number line. This symbol is there means open interval. This symbol is there means closed interval. Number 3. Number 3, left open. Left open. Open means small bracket. Left side open. So A, that means right side closed. Left side open, right side closed. That is called left open. Number 4, right open. No? Yes. Okay, number is different. Right open. Right open means left close, right open, open, open. I hope you understand. So for open, this is the symbol. For close, equal must be there. So how to write? X belongs to R such that X A. Now left open, A is open, but B is closed. For close this one. That means X is greater than 2, but while writing the elements we will not write 2. And X is smaller than equal to 7, but we will write 7. Already I explained here. So this one means X belongs to real numbers. X. Here we will put equal sign because A is closed. right close, sorry, something wrong. Okay, right open, right open, left open, right open. Now symbol, how to express in number line. A, B, A, B. Now here left open, open left. So this way. B is closed, B closed. Here A closed, B open, A closed, left open, A arrow mark is there. That means A is not included. A is crossed. Arrow mark means crossed. Here it is a wall. That means B, at B wall is there. That means B is there. So you can understand that way. So what we have learned: open interval, closed interval, left open, right open. If you remember, if you understand open and closed, when open, A and B will not be included. If it is closed, A and B will be included, and left open, right open. So you understand that. So here some examples are there. Show the following intervals in number lengths -3, 4. Open interval. Open interval. So -3, 4. So arrow mark will be there. 2, 5. 2, 5. 2 is open, left open. 5 is closed. So 5 will be included, but 2 will not be included. Look here. This is number line 0, 1, 2, 3, 4, 5, 6. This one 2, 5, left open. That means 2 is not included. After just 2, we will mark here. After just 2, we will mark here, but till 5. Till 5. Till 5. Okay? Till 5. We will join here 5 directly, but here we will not join because 2 is not included. It means what? X this way. And it means 3, 4, 5. X is greater than 2. So we will start from 3. X is smaller than equal to 5. Equal is there. So we will use 5. So that means after 2. After 2, 2.1 is also, look here, 2.1 is also greater than 2. X is greater than 2. So 2.1, 2.2, 2.01, 2.001. So after just 2, everything will be greater than 2, correct? So you understand, I think. So this way you can understand this one also. This is both sides closed. So arrow mark. -5 is included, 4 is also included. Both sides closed. It means this way. I hope you understand. X is greater than equal to -5 and less than equal to 4. Less than equal to 4. So 4 and -5 both are included till 4 till -5. Example to write the power set of set 1, 3, 5. What is the number of elements? Okay. Suppose set A 1, 3. This power set, I already explained. Let me explain again. The question is to write the power set of set. So let me write power set. Power set. So first of all, let us make sure how many subsets we will get. 8. 1, 2, 3. So 2 to the power 3. 2 to the power 3 is 8. So here whatever subsets we will write, after writing we must verify whether we have written 8 subsets or not. Let us write 1, 1. Single, single. Single finished. Now double. Then triple. Then 5. Closed. 1, 2, 3, 4, 5, 6, 7, 8. So 8 subsets we have got. Power set is written. So this is finished. This is very simple. Once you understand how to write one single first, double for next, then third. But you don't think that you have to write 5, 3, 1 also. It is 1, 3, 5 or 5, 3, 1 same. 3, 5 or 5, 3, same meaning as we have already told. A is subset of B and B is subset of A, then A is equal to B. 3, 5 or 5, 3, both are same. Even 5, 3, 3 also same, because 3 twice, then we will use 1 only, once. Venn diagram. So Venn diagram is an interesting diagram for chapter set. Venn diagram has got important role for set. Once you understand Venn diagram, then you will never do any mistake in sets. Anyway, Venn diagram was invented by John Venn. First represented a set in diagram with group elements. Venn diagram is also an easy tool to determine the validity of a logical conclusion. Observe how the sets has been expressed by Venn diagram. Okay. So Venn diagram, first of all, it is related to universal set. Universal set. There will be always a box, rectangular box. Inside this rectangular box, we will have to represent the sets by circles. Circles. This is a set A, suppose. This is a set B, suppose. This is a set C, suppose. So many more sets can be represented inside the box. They are sets. As a whole, this box is universal set. For example, I will show you now. Universal set, let me write 1, 2, like this till, let me write 3, 4, 5, 6, 7, 8, 9, 10. A, 1, 2, 3, 4. B, 7, 8. So now how to represent in when I have written one universal set, another two sets I have written here. So how to represent this sets in Venn diagram? First of all, there should be a box. So my diagram is not so good, but you will use scale or ruler. So for box, after drawing this box, you must write that is U. That means this box is an universal set. A. This is a set A and this is a set B. Should be circle, okay? Should be circle, not egg. Don't make the shape like egg. Anyway, this should be a circle. A. This is A and this is B. This is how you have to write. This circle is for set A. This circle is for set B. A 1, 2, 3, 4. 1, 2, 3, 4. So 4 elements are there. Inside the circle A, written 4 elements. B 7, 8. 7, 8. Okay. Now this box includes two sets. But this box means what? 1 to 10. This box means 1 to 10. Inside the box now we have written 1, 2. Forget about these circles now for time being. Inside the box we have written total 1, 2, 3, 4, 5, 6 elements we have written. But here 10 elements are there. Inside the box what we have written? 1, 2, 3, 4, 7 and 8. These tick marks elements are already there inside the box. I hope you understand. Now those tick marks are not there. They are not written. So let us write what? 5, 6. 5, 6, 9, 10. 5, 6, 9 and 10 we have not included in the set. Because 5, 6, 9, 10 they are not present either in A or in B. So we have written outside the circles but inside the box. So now for inside the box, for time being forget about the circles. For time being. Then inside the box only numbers are there, elements are there. Forget about the circles. Then how to read? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is what called Venn diagram. This is what called Venn diagram. Now, if it is like this, here between A and B no common elements. Suppose between A and B common elements are there, then how we will draw the Venn diagram? Now 3, 4 and 3, 4, two elements I have kept common. Then how to draw the Venn diagram? First, as I have told you, first the rectangle that will be denoted by capital letter of A. Now this circle I have drawn for A, set A, and another circle I am going to draw for set B. Here set A for circle for set A and circle for set B I have drawn separately because A and B they don't have any common elements. But here circle for set A already drawn. Now I am going to draw circle for set B, but I am not going to draw the circle for set B separately. I am not going to draw that because A and B both have got two elements common. So we will draw this way. Both they will cross each other. Both they will intersect each other. So this is the space for common elements. 3 and 4, 3 and 4. So this is the circle for A. Inside this circle 3, 4. Inside the circle B also. When you think of B, forget about circle A. When you think of A, circle A, then forget about B. Let me rub this one. Now this is clearly a circle A in which 3, 4 there is. 1, 2 also there are. 1, 2, 3, 4. I have done 1, 2, 3, 4. 3, 4 why I have kept here? Because these are the elements for B also. Now this way. Now let me rub this part. So get this circle now. This is a circle for B in which 3, 4, 5, 9. 3, 4, 5, 9. So this is clearly those elements for circle B. 3, 4, 5, 9. So this is the circle for B. So in which 4 elements are there and they are 3, 4, 5, 9. I hope you understand. So let us write this one now. So for A and for B, 3, 4 common elements. So we don't have to write double. 3, 4 we have kept in the middle. This is the space which is called common space for both set A and B. Still the work is not finished. The Venn diagram is not completed because this is U. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this Venn diagram is completed. This 6, 7, 8 and 10, we will not write those 4 elements inside the circle A nor inside the circle B because they are not the elements of set A and B. I hope you understand the Venn diagram clearly. Illustration. Before I do this illustration, let me explain one more example for Venn diagram. U 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A 1, 2, 3, 4. B 3, 4, 5, 9. C 3, 4, 6. I have written 3 more sets. In previous example, we did only for 2 sets. One universal set, there were 2 sets. Now I have written 3 sets. How to express it in Venn diagram? Let us draw for this circle for set A. After that, to draw B, we have to check first whether there are any elements common for both A and B. We have seen that 3, 4, 3, 4, yes, common elements are there. So we will cross the circle B also. Now, question of C. Now, how will you draw C? If we draw C like this is C, that will be wrong. Why it is wrong? Because this is the common space for B and C only, not for A. But we have seen in A 3, in B 3, C also 3. That means one common element is there, one more is there. So two elements are common for all the three sets. So there should be a one space which should be common for all the three sets. So that is a very common sense. Okay, so we will draw a circle here like this. This is set C. This is the place for common, this is the common space, common place for A, B, C, because this is touching, this is surrounded by, this is surrounded by, this is surrounded by three circles, all the three circles. This is the common place for all the three circles. Now we will write the elements. I hope you understand. This place is for A and B. This place is for A and C. This place is for B and C. I hope you understand. Now let us do first this one. 3 and 4. Because 3, 4, these two elements are common for all the three sets. So this is the common for all three. Okay. Now A 1, 2, 3, 4. This is the circle for A. So 1, 2. So think about this circle. Inside this circle, 4 elements are there or not? 1, 2, 3, 4. Those 4 elements are there inside this circle. So very carefully you have to write. B 3, 4, 5, 9. This is the circle for B. Okay. Inside this circle already 3, 4 they are present. Only we have to write 5, 9. Now C. This is the circle for C. Inside this circle only 2 elements are there. They are 3, 4. 3, 4. So we will write here 6. We will not write here or here 6. That will be wrong. Because this is the space for A and C common. This is the common space for A and C. But 6 is not common for A and C. Neither 6 is present in A nor present in B. So we cannot make it common for A and B. I hope you understand. Still, we have not yet finished the completion of Venn diagram. Because 1 to 10 it is. Universal set is 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now it is complete. Now it is complete. Now, let me show you something else. 3, 4. Suppose 5, 6. Now the diagram will be different. Now between B and C, these 3 elements are common. Between B and C. Look here. B and C. B and C. This is B and this is C. We will for time being just remove A. Forget about A. This is B and this is C. This is the common space for B and C. Inside this common space only 3, 4 are there. For B and C I am saying. I hope you understand. But for B and C there are 3 elements. 3, 4 and 5. 3, 4 and 5. So this is the place where we have to write 5 also. We have to write 5 also. So from here we will remove. Okay, I hope you understand. This is the circle for B. Inside the circle B, let us see elements are present or not. 3, 4, 5, 9. 3, 4, 5, 9. This is the circle for C. Let us see elements are there or not. 3, 4, 5, 6. Inside this circle for C, 3, 4, 5, 6. Now let us join. Okay, I hope you understand. So you have to understand, you have to identify the space for common space. So look here, there are 60 students in a class. This is illustration given in the book, so let me explain it. 60 students in the class. So total students 60. So you will be universal set is 60. A is set of all students who can speak Assamese. Sorry, here out of 35 students speak. Out of those 35 students speak Assamese. Assamese 35. Assamese speaking students 35. 20 speaks Hindi. 20 students can speak Hindi and 10 speak both the language. A and H, Assamese and Hindi. Both the language they can speak. That means 10 is common for set A and set H, like this. Okay, that is why for set A and set H, this is the place kept for common, in which 10 written. This is Assamese speaking, this is Hindi speaking. Common speaking 10. So that is why 10 is kept. This is U. Okay, I hope you understand. Out of those 35 students speaking Assamese only, 20 speaks 20, 10, so 10. This is the Venn diagram. The set of all the students who cannot speak both the languages. So D is okay. Look here. This is the circle for A. This is the circle for H. Means A means Assamese, H means Hindi, C means both the language. So out of this circle, those students neither they can speak Assamese nor they can speak Hindi. So that is why it is put dot dot dot. This is kept blank. So this 35, 10, 20, these students are here. So out of this, our rest of the students, they cannot speak Assamese, they cannot speak Hindi. So that is D. D is kept. D can be written here also. Here also, because these are all our students for D. Set of all students who cannot speak both the language. This is given in the book, so you can understand that. Complement set of a set. Complement. Okay, let me explain one set. This is U. A 1, 2, 3, 4. U 1, 2 like this till 10. U is universal set. B 4, 5, 6. Okay. Two sets I have written here. A 1, 2, 3, 4. 4 elements are there. B has got 3 elements. Universal set is 1 to 10. So inside the box there must be 1 to 10. Okay. Now let me draw the Venn diagram for A. Means circle for A. And B also. Okay, for time being, you will not understand. For time being, I am not going to keep common elements for A and B. So separately, there is no common element between A and B. So I have not drawn crossing each other. So I have drawn separately. A means 1, 2, 3, 4. B means 5, 6. So 7, 8, 9, 10. They will be out of the circles. I hope you understand. Now, complement set of a set. Then, so what is the complement? Complement means remember not. Remember that is not. So if it is a complement, so symbol is either this or you can write a dash. Anyone can be used. A complement means not A. B complement means not be. Remember this word, not. Complement means not. So A complement means not 1, 2, 3, 4. B complement means not 5, 6. So let us write now. A complement is equal to, we will write all the elements from U excluding A. All the elements we will write from U excluding A, not A. 1, 2, 3, 4 we will not write, but we will write 5, 6, 7, 8, 9, 10. This is called A complement. B complement. B complement means not B. 5, 6 we will not write. Except 5, 6, rest of the elements from U we will write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is what called complement of a set. So complement means there must be a universal set. Without universal set we cannot find out complement. So what does it mean? Shortly, in rule method we have to write A complement is equal to X oblique X belongs to U but X does not belong to A. This is rule method. This is roster method, writing the elements directly. Here not writing the elements directly. X belongs to U. A complement means X. These are all in U but not in A. 5, 6, 7, 8, 9, 10, they are not in A. They are not in A. Not does not belong to A. I hope you understand. So for B complement, X oblique X belongs to U but X does not belong to B. I hope you understand clearly. X, which are the X? 1, 2, 3, 4, 7, 8, 9, 10. They are X. They belongs to U. But they do not belong to B. 1, 2, 3, 4, 7, 8, 9, 10. They are not present in B. So they are not present in B. I hope you understand clearly. Here example is there. U 2, 4, 6, 8, 10, 12 till 20. A is given 10, 12, 14, 16. And A complement we have to find out. A complement. A complement to find out, no? Yes. A complement means, look here, A complement means not A. So 10, 10, 0. 10 minus 10, 0 means 12 minus 12, 0. 14 minus 14, 0. 16 minus 16, 0. That means 10, 12, 14, 16 we will not write. But rest we will write 2, 4, 6, 8. 10 we will not write. Till 16 we will not write. 18, 20. I hope you understand. 2, 4, 6, 8, 18, 20. Now number 2, what is written? A complement A. This is A complement U. That means A complement we have to write the elements with respect to universal set. But here we have to write A complement of A. A complement A means A complement of A means we have to write the elements of A complement with respect to A. We have to think A as U. Look, A. Think that this is universal set. What is A? 10, 12, 14, 16. Now we have to write A complement. A complement with respect to A. This is written A complement with respect to U. That means we have got the relation with U. But here A complement A. A complement A we have to follow A only. So not A. Not A means nothing. That means 5. A complement A, B complement B, 5. C complement C, 5. P complement P, 5. So complement of same set will be always 5. So like this. Okay, this is exercise actually. This is exercise 2.2. We will do in next video. So I hope all of you understood. All of you understood my explanation, and because this is the preliminary things you have to know and you have to learn. Otherwise, you will not be able to do sums properly or sets. And because this is a long chapter till 2.4, I think. So long chapter. So preliminary basic concepts. If you are still not clear, please pause the video, or record the video, download the video, or write it on the note copy. Then you will understand. But you have to. Otherwise, no other way. Still there is any problem, please pause the video, please download the video. Repeatedly you can watch the video, then you can understand. So till then, goodbye.